Yes, good morning to all. Am I audible? Yes. Anyone? Yeah. Okay. Okay. So in the virtual lab assignment, okay. Mm, okay. See, for design of carry look ahead adder, okay. You are supposed to download this as per your system configuration. Means if it is 64-bit version, then you can download the 64-bit version of the simulator. And suppose if it is 32-bit version, you can download the 32-bit version of the simulator. Okay. So once you download, you have to design this carry look ahead adder. Okay, here there is some mistake is there, but once you if you try with a simulator, okay, here if you design the virtual lab assignment by using these half adders, six kitna 4 plus 3 7 half adders and OR gates. Okay, so there is some mistake is there, you just find out that, and you can design this carry look ahead adder. Okay, carry look ahead adder, because in the I think I have discussed about the ripple carry adder. Okay, so you have to use this particular circuit you are performing here, because it takes time, almost half an hour time it will take. Okay, so in the next class I will discuss about this, but you can do, but this particular diagram, no, there is some mistake is there, means if you follow with same. Okay, so here in the carry look ahead adder, like a naught b naught sum and carry. So this carry, sum, and here for hop adder carry is provided, and sum is one input. Okay, but we can do, there is some mistake is there in this particular diagram. Okay, but if you follow the steps, no, these the procedure if you follow, then you can do it. Okay, in the next class we will do that. Okay, but you can do that. And in the I have shared one video also, in that ripple carry adder I have done. Okay, the ripple carry adder. Okay, so that you can do for ripple carry adder. Okay, the experiments. So this I have done, ripple carry adder, means we designed similar to this diagram. Okay, so similar to that carry look adder also you can design, but you need to spend some time, half an hour at least. Okay, we'll discuss that in the next class. Now we'll continue with your this last class content. Okay, so we discussed the reservation table, like in a linear pipeline, linear or non-linear pipeline we discussed. Okay, asynchronous and synchronous. There are two types in linear pipeline. So this reservation table, it will show the utilization pattern of successive stages. Means in this particular clock cycle 1, this particular stage is utilized. Clock cycle 2, second is utilized. Okay, so this is the representation, graphical representation. So reservation table represents the flow of data through the pipeline for one complete evaluation of a given function. It is just a graphical representation. Okay. So unifunctional pipeline only can simply use X mark in the table entry. If there are multifunctional pipeline, means if there are like multifunctional, then we use in a different way to represent. Like for example here, if multiple here only like for one stage. If there are multiple stage, then we use like A, B, or A, B, like. Okay, it is just a representation of the how the stages are resolved. So this is the structure of linear pipeline. Okay, this is basic structure of the linear pipeline processor. Means here the stage S1, stage S2, stage like S3 we can connect similar to stage SK. So these stages are connected, and between that there is a latch circuit. Okay, linear means cascade connection of the different stages. Okay, so here this is the space diagram of four stage pipeline processor, like here. Okay, this is called as space time diagram for, means this is the four stage pipeline, means they are represented in a stage and time. Okay, we'll discuss that. Okay, so this is the general diagram for linear pipeline processor, where the stages are connected in a cascaded form, and between each stages there is a latch circuit or buffer. Okay, there is a latch circuit. Okay, to store the intermediate result. Means the whatever the data from S1 to S2, it will pass through this latch circuit. Means it's a temporary storage. So this is called as linear processor for overlapped processing of multiple tasks. Overlap means in this particular time there are two operations are there. In this particular clock pulse there are three operations. Here there are four operations. Means overlapped operation. We call it as overlapped operation. Overlapped operation, right? So the diagram of four-stage pipeline processor is demonstrated. Once the pipe is filled up, it will output one result per clock period independent of the number of stages in the pipe. So here, so how this is a four-stage pipeline, right? Four-stage pipeline. Four-stage means once the pipe is filled means, for example here, during the clock cycle 1, the first instruction, it is in the first stage. During the second clock cycle, first instruction, okay, in the second stage, and second instruction in the first stage. We already gone through this one, but here you will get confusion. Like, see this is like stage S1, means like suppose if we consider instruction 1, instruction 2, instruction 3, and here stage 1 2 3. Overlapped operation. Means I already explained this, we already discussed, because as we discussed some general laundry example and all, no, now we are actually discussing in detail, means some in terms of technical, means that's why I in the previous class only I discussed some general examples, so that you should not get any confusion. So here, like here, first instruction in the first clock pulse, first instruction in the second clock pulse, first instruction in the third clock pulse, first instruction in the fourth clock pulse. If there are 4 stages, S3 S4, यहाँ क्या होता है, the second instruction in the second instruction is second clock pulse, second hmm, second instruction, first instruction, okay, time, no, okay, oh, the upper side, first instruction in the second clock pulse, first instruction in the second, here first instruction in first clock pulse, this is instruction, one indicates instruction in one first clock pulse, first instruction in second clock pulse, first instruction in third clock pulse, first instruction in no, here in this way, first instruction in first clock pulse, first instruction second clock pulse, first instruction third clock pulse, first instruction in the fourth clock pulse. Means this is the fourth clock pulse. At the end of the fourth clock pulse, a new instruction is executing, a new instruction is executing, because in the this is the upper part, okay, so here we represent, this is the part is there, no? This is called as instruction, this is instruction, and here base is there, no, that is a clock. So in the first clock pulse, first instruction is in the S1 stage. At the same time, here in the second clock pulse, okay, second clock pulse, what happens, the first instruction in the second, means here, then at the same time the second instruction is fetched here, okay, and here in the third clock pulse, what happens, the first instruction is in the third stage, second instruction in the second stage, third instruction in the first stage, okay, so this is called as stage, कौन सा स्टेज में कौन सा इंस्ट्रक्शन है, okay. So here in the fourth clock cycle, first instruction is in the fourth stage, means in our case there are only 4 stages are there, means the pipe is filled. Pipe means, like for example here all the 4 stages 1 2 3 4, ये चारों स्टेज एंड आया तो means it is pipe is filled, okay, means you are getting output here next stage, okay. So I hope you are getting, means this is called as a time space diagram, means the representation of the overlapped operation, okay. In the first instruction in the first stage. First instruction during the second clock cycle, first instruction in the second stage here, and at the same time during this clock pulse, second instruction is in the first stage, because S1 means first stage. Okay, here during the third clock cycle, first instruction in third stage, second instruction in second stage, third instruction is there, no, that is in the first stage. Okay, that only we discussed, normally we general in the initial, these are the instructions. Yeah, 1 2 3 4 5. So during the first clock pulse, first instruction in the first stage. Okay, first instruction in the first stage. सेकेंड क्लॉक साइकिल में क्या होता है, दिस इज इन द फर्स्ट इंस्ट्रक्शन इन द, ये ऊपर का ये इंस्ट्रक्शन करो और ये स्टेज करो. सो हियर द फर्स्ट इंस्ट्रक्शन इन द सेकेंड स्टेज at the same time second instruction in the first stage. Okay, during the third clock cycle, okay, clock cycle, what happened, the first instruction in the third stage, okay, and the second instruction in the second stage, and third instruction in the first stage during the third clock cycle. I mean, this is an overlapped operation. I mean, this particular time, okay, all the stages are reserved. Okay, so like you can see here, this general example here, we can see first instruction here, it is a fetch stage. During the second clock cycle, the first instruction is in the decoding stage. At the same time, second instruction is fetched. I mean, this is overlapped operation during the one clock cycle. During the third clock cycle, first instruction is in the execution stage, means one third stage. Execution means third. See here, F1 means first stage, decode means second stage, execution means third stage, and write result means fourth stage. ऐसे चार stages है pipeline. Then one instruction is executed. Okay, this is first phase, second phase, third phase, and fourth phase. Okay, so don't get confused. Time space diagram. Okay, here, like in the fourth clock cycle, the first instruction in the fourth stage, means here total we have 4 stages. So here at the end of the clock, one instruction is the first instruction executed successfully. The first instruction executed successfully. Okay, during this particular fifth clock cycle, what happens, the second instruction is executed successfully. In the next clock cycle, sixth clock cycle, third instruction is executed successfully. So after every one clock cycle, okay, a new instruction is executed successfully. A new instruction is executed successfully. A new instruction is executed successfully. New instruction is executed successfully. So this is called time space diagram. Okay, this is called as time space diagram. the time space time, sorry, not time space, we call it as space time diagram, that is showing the overlapped operation. Stages versus time. Then clock period. So the logical circuitry in each stage Si has a time delay denoted by tau I. So the tau is equal to maximum, the delay, tau I means the maximum delay plus tau 1. You just remember this formula. Okay, tau time equal to tau m plus tau 1, or just frequency, the time period they will give. Okay, f is equal to 1 by t. Okay, so the clock period, f is equal to 1 by t. You just remember this one. In the exam, they are actually gate level questions you will get in the pipeline. Gate levels, so they will give the time period, how much time is required, t. Okay, t value they will give, means this one. So how you calculate the speed up in a linear pipeline for k stages can process n task. K stages means like here s1, s2. K stages can process the n task, n number of tasks, means instructions, in k plus n minus 1 clock cycles, where k cycles are needed to complete the execution of the very first task. And the remaining, see here, because यहाँ क्या होता है कि here up to this k cycle, okay, कितना stages है ना उतना, okay, up to k cycle, okay, यहाँ क्या हुआ, one instruction, first instruction is executed at the end of the clock cycle 4. After this, in every one clock, at the end of the 5th clock cycle, second instruction is executing. At the end of the clock cycle 6, third instruction is executed. Okay, so k cycles are needed to complete the execution of very first task. See, first task only it takes the maximum time. Okay, so k cycles, that is why k plus means this is for the one instruction. Okay, k plus, and remaining n minus 1 task means there are n task is there. Okay, n task, and for one task k cycle is required. Okay, तो remaining कितना बचा, n minus 1, n minus 1. Okay, n minus 1, and for that n minus 1 cycle is required, क्योंकि at the end of the here up to this 4 stage का 4 up to this 4 clock cycles are there, no, it required k cycle to execute the first instruction. This is first instruction. यहाँ जब यहाँ तक है ना, this is the first instruction. This is the first instruction. Okay, then in the next 5th clock cycle, here the second instruction is executed, third instruction is executed, fourth instruction is executed, fifth, likewise continuous. Okay, so first instruction के लिए k cycle, k plus, for remaining n minus 1 instruction, n minus 1 cycle into t. Formula you have to remember this one, tk is equal to k plus n minus 1 into t. This is t is the clock period, so that is the speed up formula. I hope you are getting. First instruction के लिए k cycle, और next n minus 1 cycle, n minus 1 instructions, क्योंकि एक instruction गया ना, तो remaining कितना बचा, वे 100 इंस्ट्रक्शंस है, तो फर्स्ट इंस्ट्रक्शन के लिए ज़्यादा टाइम लगेगा, जो भी वो पाइपलाइन फिल होने तक, के साइकिल। ओके, तो रिमेनिंग कितना बचा, और 99 साइकिल्स बचे। सो दैट इज n माइनस 1, 100 माइनस 1। The efficiency, the product of time interval and stage space in the space-time diagram is called as time-space span. A given time-space span can either be busy state or an idle state, but not both. The efficiency is calculated in linear pipeline by the percentage of busy time space spans over the total time space span. So for that, the formula is efficiency neta is equal to, you just remember this formula. Okay, here they are written like n is the number of task pipeline stages and clock period of the linear pipeline divided by k into k tau plus n minus 1 into tau. So here this tau is taken common, tau into k. If you take common, so you will get this one. So efficiency is just, you can remember the formula, n divided by k plus n minus 1. Efficiency. Okay, then speed up का formula क्या है, k plus n minus 1 into tau. K plus n minus 1 into tau, t, time t. This is speed up and this is efficiency. Throughput is calculated by efficiency by t. The number of tasks can be completed in a pipeline per unit is called as throughput. Okay, so the throughput is n divided by k into tau, n minus 1 into tau. So this is efficiency formula, you know, like n divided by k plus n minus 1. So here this is efficiency. This f is equal to 1 by t, so that's one neta by t, that is your throughput. I think I have some problems here. So here the instruction pipeline of a RISC processor has the following stages: instruction fetch, decoding stage, operand fetch, operation, perform operation, write back. So total there are five stages are there, 5 stages, and they take the one clock cycle each for every instruction. Consider a sequence of 100 instructions, 100 tasks. Okay, 100 instructions means 100 tasks. In the perform operation stage, 40 instructions take 30 cycles. In the perform operation, this is a particular stage, in that 40 instructions taking 3 clock cycle, means it is taking more clock cycles. Then 35 instruction takes 2 clock cycles, means it is taking one more extra clock cycle, and remaining 25 instructions they're taking 1 clock cycle each. Assume that there are no data hazard and no control hazard. The number of clock cycles required for completion of execution of the sequence instruction is. Okay. So this type of questions, and here in the examination they won't in the gate exam they won't give the options. Okay. In the gate exam, no, you will get numerical type of questions. Numerical type of question means उसमें क्या करना पड़ेगा? It's like a fill in the blanks. You have to calculate and you have to fill the value. Okay. So in the nowadays in the gate exam, almost around 10 to 15% questions are numerical type. Means you cannot guess there. If you know the formula and all, then only you can apply. So here there are 5 stages they are given, and there are 100 instructions are there. Okay. 100 instruction in a pipeline here, like as a 5 stages they have. First stage क्या है? Instruction fetch. Second stage क्या है? Instruction decode. Third stage क्या है? Operand fetch. Fourth is perform operation, then write back. वैसे 5 stages दिया है, and कितने instructions है? 100 instructions. But ये जो perform operation stage है ना, so इसमें क्या होता है? इसमें थोड़ा गड़बड़ है. गड़बड़ मीन्स क्या? It is taking more time. Like 40 instructions are takes 3 clock cycle. 35 out of 100, no. 40 instruction 30 clock cycle, 35 instruction 2 clock cycle, then 25 instructions 1 clock cycle. Okay. Actually normally it is taking one clock cycle, but in the perform operation there are 40 instructions are there. Any 40 instruction that is taking 3 clock cycles. So you have to calculate the number of cycles required for completion of execution of the sequence of instruction. So the answer, so how you can calculate? See here the number of instructions are n is 100. How many stages are there? K is equal to 5. If the n instruction takes C cycle, so if n instructions take C cycle, then so C minus 1 stalls will occur for these instructions. तो फार्मूला क्या था? n plus k minus 1. Okay. The number of clock cycles required equal to total number of cycles required for general case plus extra cycles are required here for PO stage. So this is the formula for general case, n plus k minus 1. Okay. यहाँ extra cycles भी है ना, perform operation stage में it is taking some extra cycles. See here 100 plus 5 minus 1. Okay, क्योंकि 100 instructions 5 stages are there. Extra cycle 40 instructions are there. तो उसको कितना 3 cycle चाहिए. So one is required here, जनरल केस में कंसिडर हो जाता है वो. तो रिमेनिंग कितना? दैट इज 2 cycles प्लस 35 instructions taking 2 clock cycles, so that is 2 minus 1. क्योंकि जनरल में ये कंसिडर हो जाता है वो. नॉर्मली इट इज सपोज टू टेक 1 इंस्ट्रक्शन, बट पीओ स्टेज में क्या हो रहा है? वो एक इंस्ट्रक्शन 3 साइकिल ले रहा है. 3 मीन्स एक तो लेना ही था, 2 एक्स्ट्रा ले रहा है. सो दैट्स वाई 2 minus 1 प्लस 25 into 1 minus 1. तो ऐसे यहाँ कितना होता है? -496, नो. 100 प्लस 104 प्लस हियर 40 into 2. 40 into 2 is 80. 35 and next is 0. So it is 104 115 219 cycles. So like such type of problems you will get. Actually here they given the option, but here in the examination you won't get. You directly you have to type there. You have to type the answer as 219 cycles. Means for 100 instructions, as per the given problem statement, 100 instruction के लिए 219 clock cycles चाहिए to execute 100 instructions with these changes. Means here PO stage taking some 40 instructions are taking 2 extra clock cycles, 35 इंस्ट्रक्शन टेकिंग 2 एक्स्ट्रा मीन्स एक तो लेना ही चाहिए बट और एक एक्स्ट्रा ले रहा है, यहाँ 3 है ना, वन साइकिल इज फिक्स्ड but it is taking 2 extra cycle here, so that is 3 clock cycles. Okay, so such type of questions you will get in the examination. Speed up and to calculate the efficiency. Okay, so this is for the speed up. Tk is equal to k plus n minus 1 into tau t. Efficiency is n divided by k plus n minus 1. Throughput is n divided by tau. Not n, it is neta. Efficiency divided by tau. Okay, so this is all about the linear pipeline. Okay, so other concepts we will discuss. Okay, and next class I will discuss that carry look ahead adder. You also try it. That carry look ahead adder is there, no? So you also can try it. But sir, there is some mistake is there in the this particular means you have to follow this theory and all. You follow this diagram, no? There is some mistake is there that you find out that means if you draw if you design the virtual lab assignment with respect to this circuit diagram, no, you will get a wrong result. Is anyone tried with this? Yes, anyone tried? Simulator is not working in. It is unable to see. You are required to use the this Java file. Java software should be there in your system, and also you can use this particular link. This software is there, no, like here. As per see here, you may get java.com means Java runtime environment is needed to get this software. 64-bit machine and 32-bit machine alag depend upon your system configuration you use. Once the simulator is downloaded, open the command prompt, then go to the directory where you have saved and use the cd command, then give the following command to run the simulator. It is a jar file, no, so that's why you try this also, but it will work. Okay, Java रहना चाहिए and you check it out your machine, 64-bit machine or 32-bit machine. Okay, based upon that you can use. Yes, roll number 2, are you there?
Yes, sir.
So have what problem means is there Java in your system?
Yes, sir. I have downloaded the Java environment, but also it is not opening, sir.
Have you can you try with this method with command prompt?
Okay, sir. I will try.
Hmm. And you can use this link, IIT Kharagpur link is there, no? You can use this one. Okay. You just search it virtual lab IIT Kharagpur, because there are 2-3 links are there, but you just go through with the IIT Kharagpur link. Okay, so you can leave.